in continuity of what I was talking to you, the regarding the role of the meta surface, um, as I told you before, this meta surface is designed to tilt the angle of reflection toward 41 degrees. As the flat surface, it is almost impossible in the past, but now it is possible by us to make a change in the flat surface to have a very special function like that. So the incoming wave is hitting the surface and the reflection occurs to the surface, but with the 41 degrees of angle inclination coming. Still, probe is waiting for the receiving energy or incoming reflected energy to detect.
I
Here.
have two versions
So
of
if you
probe.
remember here, this
Stationary
position,
one, like this, with the tripod,
the
and
probe has
held.
not changed
You can
the
find them under the name of
angular
TexWave
position.
5G.
It keeps the 41 degrees from the previous test like this, right? But only difference we have made is the distance. The distance between the aperture of the probe to and the center of the meta surface like this. So, well, 2 times the distance we used. Now we have this probe located at farther from the surface. The reason why I had to change the position of the probe farther from the metamaterial surfaces, if you see, or
This
when
is the
you
best
see
angular
the
position,
pattern
which is targeted by the meta surface we design, and we will move the angular
farther,
position
the more
starting from 45 degrees
function. I
to
mean,
upper degree
in the near zone area,
angle of reflection and lower
there
angle of
is
reflection line.
much
We will
noise,
compare them.
like side lobes. So sometimes it is hard to distinguish the its feature at the 41 degrees or the strength at a lower degree like that. But if you move the position of the probe away to the farthest point, then the noise which was around it has been eliminated and you can get the maximum strength at this position, at this angle. So we will going to check this. Let us confirm this by changing and checking the strength of the received power. Here we will read here the strength.
This spectrum analyzer is attached through the cable to the probe.
dBms.
You can see the green marker there that tells you the strength.
The signal strength has been lower than before. Why? At the same angular position, but the distance has increased. So it is no wonder we can see the weakening of the received power strength. But it's going to be the maximum at this same radial area. The distance is the same. This angle is going to give you the maximum signal strength. So please move this to a lower angle like this. How about this?
To a lower, I'm sorry, one upper angle, a lower angle, but to this
As you
direction.
remember, in the previous test, a little bit of lower angle from the 41 degrees, such as 20 degrees, the signal strength was not ignorable. Why? I told you the near zone area is polluted with a lot of
We've
noise.
changed the
So
angle
it is
of
hard to
observation from
distinguish
45 degrees to 20 degrees,
intended
and
direction of
we expect the
reflection
decrease
and
of the signal
direction
strength
of
of the received power.
here. That's the farther point with the lower angle, but this is not the desirable angle. Desirable angle is 41 degrees here, about 20 degrees of angle. Let me check.
Let us check. Yeah, how
That
much
reads around
value?
minus 50 point something dBms. So you can see, obviously, the difference between the signal strength at the 41 degrees and the signal strength at the 20 degrees. So the noise has been removed. Why? We could do that by moving it further away from the surface of the material. Now we will change this probe to a higher degree of angle. Good. My research assistant has moved the position, angular position, from 41 or 45 degrees toward around, say for example, that is around 60 degrees or 70 degrees. We are really wondering what happens to this probe. Let us see the signal strength. That is minus 49 or minus 50 point something dBms. So the moving the probe from the
By watching
desired angle
the
to upper
animation
angle,
on the
actually,
spot, it's hard to read the tiny
signal strength of the
numbers
receiving
there.
power has
But
gone
I'm
down.
definitely telling
What we
you,
expected.
at the 45 degrees of observation, that was the best and the highest in strength, around minus 40 something dBms. But other angles have, such as such as 20 degrees or 60 degrees, it will go down by 10 dBs like that, or more than 10 dBs. 그러면 지금 시간이 거의 다 됐지만 짧게 handheld 타입도 한번 볼 수 있을까?
예, 바로 들겠습니다.
짧게 너가 스킵 해라.
Now I'm going to introduce a new probe, which is handheld. My research assistants are holding
For
this
you to
new
use
probe. Actually,
the
this
handheld
probe,
probe,
was born to
you will need extra things such as the Steadicam fixer or holder. Then
the stationary
that might be
version.
much better for
This is
you
a
to have the
handheld,
right answers.
version instead of being stationary. So stationary version was held by the tripod, but you can hold it with your hand. Now it is positioned at the angular position of 41 degrees. If you extend the line from the center of the metasurface to this is 41 or 45 degrees. So minus 41 dBms is read there.
You see a spike there?
This is hopefully the strongest point.
That means,
in the angular,
at that position, angular position, or in the azimuth plane, that has a certain value of strength.
더 좋아졌어요.
Yes, then a lower angle, such as 20 or a kind of extremely lower angle,
near field
just
region or Fresnel region,
7
that's
degrees
why
or something.
even at a lower degree of angle for the reflection, you can get not ignorable signal strength. But what happens to the change to a higher angle? 얼마?
지금 마이너스 43 정도.
Handheld probe to the 80 degrees or 90 degrees.
It is quite compatible and have a consistent result for analysis.
Goes down.
I mean the results, the value